Hello everyone, in this video we are going to talk about Shell's Scotford complex in Canada. Our group consists of me, Nurul Natasha, Lee Chi-En, Susmitach Anraj and Aiman Abdullah. In today's video, we will going to introduce the Shell background information, explain the process implemented, explain the product of the company and also discuss the latest advancement adopted by the refinery. So first, let's start with the background information. The Shell Scotford complex, located near Edmonton, Alberta, is a key facility in Shell Global Energy Network. Since 1984, it has been integral to Canada's energy infrastructure, showcasing an innovative and integrated approach to energy production. About the core operation, the complex comprises of a bitumen upgrader, oil refinery and chemical plants, enabling it to process oil sand into synthetic crude oil and produce fuel and essential chemicals that support various industries. Next is about environmental commitment. Shell Scotford complex has a standout features in the Quest Carbon Capture and Storage (CCS) facility, one of the world's first large-scale CCS project. It captures over 1 million tons of carbon dioxide annually, reinforcing Shell's commitment to sustainability and climate action.
Next, what are the processes that are implemented at Shell Scotford complex in Canada? Firstly, atmospheric and vacuum distillation unit. They use a moderate temperature, low pressure process to separate the bitumen into its constituent hydrocarbon elements. Distillate products removed from the bitumen are pumped to the residual hydroconversion unit. Next, residual hydroconversion unit operates under high temperature and pressure to improve the quality of the bitumen by converting it to lighter, higher value hydrocarbon components. Sulfur and nitrogen are later removed in hydrotreating unit to further improve the quality of the product. Number 3. Hydrogen manufacturing unit. It produces high purity of hydrogen required as part of the conversion of bitumen to high-quality petroleum products. Number 4. Sulfur recovery unit. Sulfur is recovered from the bitumen in the upgrading process. Recovered sulfur can be converted into liquid sulfur, which enables Shell to move the sulfur to broader markets. Number 5. Solvent de-asphalting unit. It processes atmospheric residue from the residual hydroconversion unit, producing streams of both lighter oil and asphaltenes. The de-asphalted oil from the unit can either be further refined or blended directly into Shell synthetic crude products. Asphaltene from the unit can either be blended into fuel oil products or sent for gasification. Number 6. Gasification. Shell is also considering including gasification unit in association with the upgraded projects to produce hydrogen and fuel gas. Gasification maximizes the use of heaviest bitumen components called asphaltenes, providing a more complete use of bitumen resource and reducing dependence on natural gas. Number 7. AOSP Diluent Recovery Unit. AOSP stands for Athabasca Oil Sand Project. Oil sands consist of clay, sand, and other minerals coated in water and thick, viscous oil called bitumen or asphalt. To get usable oil from this mixture, producers have to separate the bitumen from the sand using hot water and then process the bitumen into crude oil. This unit processes light hydrocarbon diluent remains in the bitumen so that the bitumen can be transported by pipeline. This diluent needs to be recovered from the bitumen and recycled. To recover the light hydrocarbon diluent, the diluted bitumen mixture is heated, vaporizing the light hydrocarbon diluent product, which is then cooled into a liquid and returned to the mine for reuse. It produces a clean bitumen product that is appropriate for either blending or further processing.
Next, I will present about the product of this company. The first product is gasoline. Gasoline produced at the Shell Scotford refinery is low sulfur, containing for about 5 ppm of sulfur content. This ensures cleaner combustion, reducing emissions and meeting stringent environmental regulation. It is used as fuel for the passenger vehicle and light-duty truck. The refinery gasoline is distributed across Western Canada. Next product is diesel. The refinery produces ultra-low sulfur diesel with less than 10 ppm of sulfur content. Ultra-low sulfur diesel is essential for modern diesel engines which rely on cleaner fuel to operate efficiently and comply with emissions standards. It is used in transportation, agriculture, and also industrial. Next product is jet fuel. Aviation-grade jet fuel is manufactured to meet the stringent quality and safety standards required for commercial airlines and private aviations. Primarily, it is used by the commercial airlines, military aircraft, and also private jet. Next product is propane and butane. Propane is a byproduct of oil refinery that are versatile and clean burning fuel. It is used for residential heating and cooking, automotive propane for vehicle, industrial uses like metal cutting, and as a feedstock in petrochemical plants. Butane is a light hydrocarbon primarily used for gasoline blending during the colder month as it helps with fuel evaporations. It is used for the seasonal gasoline blending, industrial feedstock for petrochemical manufacturing. Lastly, benzene. So benzene is a clear, naturally occurring liquid hydrocarbon that is a component of crude oil and natural gas. During the refinery, benzene is separated and purified. So benzene produced at the Shell Scotford is sent to the adjacent chemical plant to manufacture the styrene monomer. So styrene monomer used as essential raw material in producing polystyrene, which is used in food containers, safety equipment, insulation, and car interiors.
Next, I'll continue with the latest advancement or technology adopted by Shell scotford Canada. Shell scotford Canada uses upgrader that utilizes the hydrogen addition technology to upgrade high viscosity extra heavy crude oil or bitumen into a wide range of synthetic crude oil products. This technology is significant for improving the quality of the upgraded product into far better quality. This includes some other units including sulfur deasphalting unit and also gasification units. For the gasification unit, the main process is the gasification of heavy oil product for the production of hydrogen and power. This technology in the hydrogen addition technology aims to maximize the use of heaviest bitumen components and reduce the dependency on natural gas. On the other hand, for the asphalting unit, it processes atmospheric residue from the residue hydrocarbonation unit or directly from the bitumen itself. Its primary function is to separate heavier components from lighter oil fraction, producing stream of both lighter oil and asphaltenes. The asphalted oil can be further refined or blended directly into the gasoline, while asphaltene can either be blended directly into the gasoline or sent for gasification.